Welcome to U7L4 two-way tables. In this lesson, we're going to talk about two-way frequency tables, how they can be used to answer questions about probability. So two-way frequency tables record data that pertains to two different categories. A lot of times, each of those two categories will have two sections pertaining to them. Sometimes it can have more than two, though. Each individual data entry is called a joint frequency. So you'll see the joint frequencies are going to be in the middle of that table. And then the total number in each row and column is called a marginal frequency. So those frequencies are basically in the margins, okay, in the right side and the bottom. And then the grand total or the universal set, right, is going to be in that bottom right corner. And that grand total is either going to be, you can find it three ways, right? You can find the sum of the marginal frequencies on the right side. You can find the sum of the marginal frequencies at the bottom, or you can find the sum of all the joint frequencies. And no matter what, you should end up getting this universal set or this grand total. All right, example 1. Upon exiting, passengers on a plane were asked if this was their final destination and if they checked bags. The results are shown in the table below. Complete the table by filling in the missing frequencies. Okay, so just looking at this table, we have final destination, yes or no. Okay, and then we have checked bags, yes or no. And then we have two different total sections where the marginal frequencies will be. Okay, and then, of course, the grand total here in the bottom right corner. So we're going to fill in the missing frequencies. So first of all, keep in mind that in the total row or column, that's going to be the total either counting down or across, depending on which one you're looking at. For example, if I'm looking at this one here at the bottom of the final destination yes column, that's going to be the total of 50 plus 16. So if I add those two together and I get 66, right, that's the total there. Same thing if I'm looking at final destination no. Right? Same thing. But I already have the total there, right? I already have the total here. So instead I can go backwards. If I want to find that missing table entry here, this missing joint frequency, I can take the total and I can subtract the other joint frequency from it. And then that's going to give me that other joint frequency. So 134 minus 48 gives me 86. Okay? Now I can just add. So for example, if I want the total here in check bags no, right? I just add going across. So I just add 16 plus 48 and then I get 64. And whether we add going down, whether we add going across, or whether we add all of these joint frequencies, we're going to get that same grand total, which right now in the scenario it didn't give us. So for example, if I do 136 plus 64, I get 200. I get the same thing if I add 66 plus 134. And if I were to add all four of these joint frequencies, then I should get the exact same thing. Okay, so no matter what, which of those three options I do, I'm going to get 200. And so I actually just did it on the calculator just to kind of show you visually what I was talking about here. So no matter which ones I add, so first of all, hold on, there we go. I added the marginal frequencies going down, then going across, and then I added all the joint frequencies. And no matter what, I got 200. Okay, perfect. Now let's answer the question. It says, how many had checked bags? So we go to checked bags. We go to yes, because they had them, and we go across. That is 136 people total. 136. Do the same thing here. How many were not at their final destination? So final destination, no, I was not. Go down, that's 134 total. How many had checked bags and were at their final destination? So had checked bags and were at their final destination. So this is going to be a yes to this one and a yes to this one. Okay, so yes and yes, that's 50 people. So that's how you read those tables, right? You just basically go through and you try to figure out what it's asking for, and you find the answer either in the joint or the marginal frequencies. All right, so moving on to the next page. It says, to find a certain probability given a two-way table, you must be sure to identify the desired outcomes and the total outcomes that are being asked for, right? So probability is always desired over total. And your total is often the grand total, but sometimes it's one of the marginal totals instead. It just depends on the way that things are worded. Now, I need you to add something here. It comes from conditional probability, which I didn't do a complete lesson on, but this is important for what we're about to do. So probability of A, and then it's this vertical line, which means given, B. So what this means is probability of A given B. So there are times when we're trying to find the probability of something, but we're actually given additional information. So instead of just saying, what's the probability that someone likes a certain flavor of ice cream, for example, right? I can say, given that I know this person doesn't like chocolate, right? What's the probability that they like something else? So it's just giving additional information. And what's going to happen is that is going to often change the total. And it's often going to change the desired outcome as well. All right. Example 2. Students in band were asked if they rented or owned their instrument and if they practice at home. If a student is chosen at random from the band, find each probability. So first thing I notice when I look at this table is that all of these joint frequencies are given, but there are no totals at all. There's no marginal frequency. There's no grand total. So I'm going to go ahead and fill those in now. You don't have to necessarily, but I just find it easier to complete everything if I add everything ahead of time and I have my whole table filled in. So I'm just going to start with practices and go down. That's going to be 62 plus 20, which is 82. Does not practice is 28 plus 15, which is 43. Then I'm going to go across rents. So I'm going to add a cross. So I'm going to add 62 plus 28, and that's going to be 90. And then I'm going to add 20 plus 15, and that's going to be 35. And then the grand total, I'll go ahead and put in its own box down here. Remember, I can get the grand total in 3 different ways. I can add my marginal totals, so add 90 plus 35 or 82 plus 43. And no matter what, I should get 125 when I add those. Or you can add your joint frequencies and add all 4 of them, and you should also get the 125. Okay, so how many students rent an instrument? This is just how many. This isn't probability. How many students rent an instrument? So go to rents and go over to the total, and that's going to be 90. How many students own an instrument and practice at home? So they own an instrument and they practice at home. So that's going to be 20. How many students practice or rent an instrument? Okay, be very careful here. Or, that means it's everybody who practices plus everybody who rents. So everybody who practices and everybody who rents, just don't count students twice. So everybody that practices, everybody that rents. I find it easiest to go to one of them first. So who practices? If I go down, that's 82. And then go to whoever rents, who I haven't counted yet. So I've already counted the 62 and the 20. So in the rents category, right, the only one I haven't counted is the 28. So you can't go over to the total because then that's counting the 62 twice. And we cannot do that. So again, one more time, when you're trying to figure out the or situation, you have to figure out anybody who practices or rents, but you cannot count anybody more than once. So practices is 62 and 20, which equals the 82. Okay, and then rents, we already counted the 62, so we can also count the 28. So basically, we're adding the 62, the 28, and the 20. Okay, we're adding those 3 numbers together, but we can't add the 62 more than once. So this is going to be the 62 plus the 20 plus the 28, okay? And so that's going to end up being 60, 70, 80, 90, 110. Okay, 110 people. Perfect. Okay, and now let's look at the next question. It says P does not practice. So that's probability now. When you see an uppercase, right? P, that's probability. So what's the probability that they do not practice? Well, we're talking about everybody who was surveyed. So that's the 125. That's that grand total. Okay, so we're talking about 125. Does not practice. So if we look at our table, does not practice is 43 people. There's 43 people who do not practice at home. Okay, so that's 43. This doesn't simplify. You can double check if you want to, but that doesn't simplify. So I'm just going to divide it, and I get 0.344. And I'm going to move my decimal 2 places to the right. And I'm going to get 34.4%. That's the probability that somebody does not practice. All right, keep going. So probability that they practice and rent. So again, there's 125 total. Let's find how many practice and rent. Practice and rent. That's 62. That's where they intersect. Practice and rent. They intersect at 62. So that's 62. You can go ahead and try to simplify it. but this one does not simplify either. So we're just going to divide it. So 62 divided by 125. I'm just dividing it in the calculator, and I'm getting 0.496. And then I'm just multiplying by 100 or moving the decimal 2 places to the right to turn that into a percent. Perfect. All right, keep going. Okay, for F, probability does not practice or owns. Be very careful with the ors. This is what I told you in the last problem, or on part C of this problem, really. Be very careful with this. So we know that it's still the same total. They haven't given us any additional information, so it's still 125. But we need to find anybody who does not practice or owns. Anybody who does not practice or owns. So does not practice is 28 and 15. Owns is 20 and 15, but we've already counted the 15. So now we're just counting the 20, the 28, and the 15. The 20, the 28, and the 15. Okay? So 20, 28, and 15. 20 plus 28 plus 15. Add those all up. And then you're going to get 48 plus 15, which is 63. So it's 63 out of 125. I don't believe that simplifies, so we will just divide it. 63 divided by 125, and we get 0.504, aka move the decimal. About 50.4% of people they do not practice or they own. All right, here's another probability for G. Probability that they rent or they do not practice, right? Rents or does not practice. You might want to pause the video and try this one and then check your work. So the total should still be 125 for this one. Okay, but that numerator is going to differ. So rents or does not practice. So rents is 62 and 28. Does not practice is 28 and 15. That's going to be the 3, 62, 28, and 15. So basically 90 plus 15. 62, 28, and 15. Which is 90 plus 15, which is 105. Over 125. This one does simplify, so in the calculator, if you want to, you can go ahead and simplify it in the calculator using the alpha button and the one next to it, if you're using one of the ones at school. Otherwise, they both divide by 5, and we end up with 21 over 25. And then we go ahead and we divide 21 divided by 25, and we get 0.84. AKA as a percentage, we're looking at 84%. All right, let's keep going. So now we're looking at example 3. A restaurant has chocolate, strawberry, or vanilla ice cream that is available in a cup or a cone. The table below gives the choices of the last 200 people who ordered ice cream, with some entries missing. Complete the table below, then find each probability. So we have a table. Let's go ahead and look at it real quick. It has cup or cone, and then the total. And then it has chocolate, strawberry, or vanilla, and then the total. So the two ways, right, in terms of the two-way frequency, is flavors, and then we're looking at basically the vessel, right? Like, how are you getting the ice cream? All right, so let's fill in this table. One thing I do notice right away is that it gives me the grand total up here because there's 200 people. So I can put that in the bottom right-hand quarter to begin with. All right, now let's go from there. So, for example, I see it's going to be very easy to add up the vanilla cup or cone. So that's 18 plus 35. So that's going to be 18 plus 35 is 53. Okay, so that's 53 there. Then it looks like we're going to have to go backwards, right? So, for example, we know that there's 50 people total in the strawberry row, right? So if we do 50 minus the 22, that'll give us this joint frequency here. So 50 minus 22 is 28, and that gives us that frequency right there. Okay. And then we can now add up all the cups if we want, right? 42 plus 28 plus 18. So 42 plus 28 plus 18 is going to give us 88. And then from there, I know I have my grand total of 200. If I subtract 88 from that, it'll give me this other marginal frequency for cones. So 200 minus 88 is going to be 112. So So now what we need to do, if we want this joint frequency for chocolate and cone, we need to take our 112, which is our total, and subtract the 2 joint frequencies this time. So it's going to be 112 minus 22 minus 35. 112 minus 22 minus 35. And that's going to be 55. And then we can just add those 2 up and get our total here on the right side. So 42 plus 55. And that's going to be 97. And then I'm just going to double check. So I'm just going to double check that these marginal frequencies add to 200 and that these marginal frequencies add to 200. 97 plus 50 plus 53. Yeah. Okay. And then, of course, you can double check if you want. Make sure all your joint frequencies add to 200 as well, just to make sure you didn't make a mistake. So 18 plus 35 plus 22 plus 28 plus 55 plus 42 is 200. So I just added these all up. All right, now we can answer our question. So first one is P, cone. What's the probability that the person chose a cone? So it doesn't say any additional information. That means the grand total is our total, so 200. There's 200 people surveyed. And cone, the total for the cones that were sold, okay, is going to be 112. So that's 112. Can definitely simplify that. It divides by 2 for sure, probably 4, maybe even 8. I'm just going to make it fast and use the alpha button in the calculator to simplify. And it looks like, yeah, it does divide by 8. So if you're doing this without the calculator, you would need to take out the common factor of 8, and you end up getting 14 over 25. We're going to go ahead and divide numerator divided by denominator. 14 divided by 25, we get 0.56. Turn that into a percent by moving the decimal, and we get 56%. So a little more than half of the people chose a cone. Now we're going to look for the probability of cup or chocolate. So be careful here. This is or. It's very easy to make a mistake. Cup or chocolate. Anything in the cup, anything in the chocolate, add them all together. So cup or chocolate. So for cup, it's going to be 42, 28, 18. Okay, I'm not going to add the total to that because that's already adding them up, right? And then chocolate, I've already done the 42, so just the 55. Okay, so it's just those 4 numbers that I'm going to add up here. So it's going to be 42 plus 28 plus 18 plus 55. Anything in cup or chocolate, not the totals, right? You're just adding each individual value for those numbers, or for those values, right? For those specific types that you're looking for, cup or chocolate. And then the total is still 200. Add them all up. So 42, we already know 42, 28, and 18 is 88, right? Because it's down here. So we just need to add 55 to 88. So that's 143. It's possible that simplifies. I'm actually just going to use the fraction button in my calculator to check quickly. It does not, so I'm just going to divide it. And I get 0.715. And I'm going to go ahead and change that to a percent. So it's going to be 71.5%. All right, this next one, probability vanilla or cone. So again, I need to add all vanilla and all cone. So add the vanillas. There's 2 of those. And then any cones that aren't accounted for, which is just 22 and 55. So writing all those numbers up. So 18, 35, 22, 55. 18 plus 35 plus 22 plus 55 over the grand total. So 18 and 35 is 53. And then I'll just add 22 and 55 to that. And that's going to be 130. Take out the factor of 10 that they have in common. That's going to be 13 over 20. 13 divided by 20 is going to give us 0.65. As a percent, that's going to give us 65% for that problem. Perfect. Now we have a couple more to look at. For this next one, we see this vertical line that we talked about earlier, right here, this vertical line. That means given. So this one means probability of a cup given not vanilla. Okay, so probability of a cup given it's not vanilla. So this is our new total. Our new total is all of the flavors that were not vanilla that were chosen. So our new total is not vanilla, so it's basically chocolate or strawberry. Everything that's not vanilla. Chocolate or strawberry. Let me fix that real quick. Okay, so anything that's not vanilla is going to give us our new total, and then inside of that new total, inside of anything that's not vanilla, we'll figure out how many were cups, okay? So not vanilla. So not vanilla, which means we're adding the strawberries or the chocolate flavors. So 97 plus 50. So 97 plus 50 is our new total. 97 plus 50 is our new total. We're not talking about everything this time. And then the cups within there. So if I'm looking at just chocolate and strawberry, and I'm looking at the cups inside of there, it's just 42 plus 28. 42 plus 28. I can't include the vanilla, which is 18. I can only include the other two that are not vanilla. So 42 plus 28. So we're going to add these up. So 42 plus 28 is 70. And 97 plus 50 is 147. And then this may simplify because 147 may divide by 7. It does. It's 21. So if we divide both by 7 or use any type of simplifying you can, you'll get 10 over 21. Divide that and you will get... so this is one that doesn't terminate. We'll go ahead and just write the first 3 after the decimal. So let me just go ahead and show you. So it's 0.476, and I'll just round at the 6. So 0.476. So 0.476. And then go ahead and move our decimal. So that's going to be 47.6%. All right, let's look at these last two. So for E, it's probability of strawberry given it's a cone. Given it's a cone. So again, the fact that it's a cone gives us a new total. And then we can only look at the strawberries within cone, right? Strawberries that were inside of the part of the table that is already talking about cones only. All right, so let's take a look. So we know it's a cone. We're given it's a cone. So we're looking at just that column. So just 112 total. So that's going to be 112 total. Okay. And then given it's strawberry. So we already know we're in the cone column. Now we're looking at strawberry. So that's 22. 22. Let's see, we can definitely divide by 2. And we're going to end up getting 11 over 56. Go ahead and divide that. And we get I have to round again, 196. Or if we move the decimal, change it to a percent, 19.6%. All right, you probably want to try the last one real quick. And then watch the video to make sure you got it right. All right, F, probability not chocolate given it's a cup. So again, cup gives us our new total. So all the cups is 88 total. So that's 88. And not chocolate, not chocolate. So we're here looking at just the cups, not chocolate, means strawberry or vanilla. So 28 plus 18. 28 plus 18. So we're going to end up with 46 out of 88. Definitely, they both divide by 2. And we get 23 over 44. 23 over 44. I'm just double checking in my calculator, and then I'm going to divide it. And 23 divided by 44 is going to give us about 52.3. Oh, let me write it as a decimal. 0.523. I do have to round up because after the 2, this was another 2, but it was 27, so I rounded up. And then this is going to give us, when I change it to a percent, 52.3%. Thanks for watching, everyone. Have a great day.